Hello students, welcome back to the lecture number 3 of chapter 5. In previous two lectures we have discussed about many new terms like sentence, statement, definition, axiom, postulates, theorems as well as corollary. We have studied that axiom and postulates are two correlated terms. Okay, they are the brother of each other. Those terms are the self-evident true statement. That means they do not need the help of others in order to be proven. We have also studied out of axiom and postulates, we can use axioms everywhere in mathematics, in algebra also. But in case of postulates, we can use it specifically in geometry. Right? And the great mathematician Euclid has given many axioms, many postulates. In this class, we are going to discuss about 7 most important axioms and 5 most important postulates given by Euclid. So let's start with the axioms. Okay, as I have told you, Euclid has given 7 most important axioms. Okay, out of which the first axiom is things which are equal to the same thing. Again, things which are equal to the same thing. For example, let us take two things. Suppose A and B. Okay, things which are equal to the same things. Suppose A is equal to C and B is also equal to C. Then they are equal to one another. If two things are equal to the same thing, then what we can conclude? We can conclude that A is equal to V. Again, if two things are equal to the same things, then these two things are equal. Okay. For example, suppose my height. Okay. Suppose my height and my brother's height. Okay. This is my brother. Okay. If my height and my brother's height are equal to my father's height. Again I am saying, if my height and my brother's height is equal to my father's height, then can I say, yes, my height is also equal to my brother's height? Yes or no? Yes, because my height is equal to my father's height. My brother's height is also equal to my father's height. That means my height and my brother's height are also equal. Okay, this is the first axiom. If two things are equal to a same thing, then these two things are equal. Understood? So this is our first axiom. Let's come to the second axiom. If equals are added to equals, okay, let us take two equals. Two equals means, suppose equals, suppose here you take 4, here you take 4. So two equals. Okay, if equals are added to equals, that means 4, if you add 4 with 5, here also you add 4 with that equal 5, then the result is here 9, here also 9. So what it says? It says if two equals are added to another two equals, or if the two equals added to the same thing, then the result are also equal. Then the wholes are also equal. Understood? If two things are equal and added to the same thing, then the result that you get also equal with each other. Understood? Similarly, coming to the third axiom. If equals are subtracted from equals, okay, let us take two equals. Suppose 10, here also 10. Okay, so from these two equals, you have to subtract another two equals. So 10 minus, suppose I subtract 5 from 10. Here also I have to subtract 5 from 10. So result is 5. Here also result is 5. So what do you get? You get if equals, that means 5, are subtracted from two equals. That is, here also 10, here also 10. Then the result that we get also equals. Okay. Results means the remainder after subtraction, they also give the same result. Okay. Fourth axiom. Things which coincide with one another are equal to one another. It means if you take two circle, okay, so this is a circle with radius 2 centimeter. Okay, this is another circle of radius same 2 centimeter. Okay, then these two circles are equal. If they will coincide with each other, coincide means if this circle has been cut out from this and paste over this circle, then what you find? You find these two circles will coincide with each other. They will just correlate with each other. Okay, if you cut out this circle and paste this circle over this circle, then the two circles will be coincided. Okay, so it is written that things which coincide with one another are equal to one another. If two circles are equal, then if you coincide them, then they will be coincided or they will be equal, or then seems to be a single circle. Okay, this is the fourth axiom. Next, the whole is greater than the part. What does it mean? The whole, suppose there is a container which contains 100-liter water. Okay, so this is known as whole. Whole means what? Total. Okay, the whole is greater than the part. Part means we have to distribute this 100-liter water into 10 bucket. Okay, 10 bucket, 8, 9 and 10. Then each bucket should contain how much water? See, 100-liter water has been distributed among 10 bucket. Then each bucket should contain how many water? 10 liter. Here also 10 liter. Here also 10 liter. Here also 10 liter. Okay, 10 liter, 10 liter, 10 liter, 10 liter. Okay, so each bucket will contain 10 liter. So these buckets are the parts. These buckets are the parts of this whole. Then what you can say? What you can conclude? You can conclude that the total amount of water present in this bucket is always greater than the amount of water present in those small buckets. Why? Because it contains 100-liter water, but each bucket contains here 10-liter water. So the whole is always greater than the part. Now it is understood, the whole is always greater than the part. Okay. Next, things which are double of the same things, okay, are equal to one another. First understand it. Things, suppose there are two things, A and B. Okay, so things which are double of the same thing. Okay, suppose there is a single thing X. Okay, these are the two distinct things, two distinct objects. If this is equal to double of X, written there, double of the same thing. If two things double of the same thing, this thing is a double of X. Similarly, B is also double of X. So it means if two things are equal to double of same thing means X, then what you can write? Then you can write A is equal to B. Okay, see, if A is equal to 2x, that means A is equal to double of X. Here also B is equal to 2x means B is equal to double of X. Then you know 2x is equal to 2x, you know it because these are the two same things. 2x is equal to 2x. Now in this 2x you can substitute A, then is equal to, in this 2x you can substitute B. So what you conclude? You conclude that if two things are equal or same to the double of the same thing, then those two things are equal. Okay. Next, things which are half of the same things. Okay. Things means you have to take two things or two objects. If things which are half of the same thing, suppose X is the common thing, okay, or same thing. So according to the statement, it is given that if A is half of this, that means X by 2. And another thing, B is also half of this, that is X by 2. Then what you can conclude? Then you can conclude that this is equal to this. How? Let's see. As you know, X by 2 is equal to X by 2. Right? Now in this place you can substitute a. Why? Because you have written a is equal to x by 2. And in this place you can substitute b, as you have written x by 2 is equal to b. So what do you get? A is equal to b. It means if two things are equal to half of the same thing, a is equal to half of x, b is also equal to half of x, then you get a is equal to b. So these 7 axioms are the most important axioms, and we are also already acquainted with it before studying it. Okay, now we will discuss about the most important 5 postulates of Euclid. Okay, so now we will discuss about the 5 most important postulates given by Euclid. So here is the first postulate. The first postulate has 2 statements. The first statement is a straight line may be drawn from one point to another point. It means we can draw a straight line starting from one point. Suppose it is a point, and you can easily draw a straight line from this point to another point B. Suppose A is a point and B is another point. Then you can draw a straight line from one point to other point. Okay. If there is a point, here also another point C and D, then through this point you can also draw a straight line. Understood? So this is the statement number 1. Now the statement number 2 tells you that given 2 distinct points. Okay, distinct means different point. The points should not coincide with each other. It means if here is a point P, then there is another point Q. So if there is 2 distinct points P and Q, there is an unique means 1. There is only one line that passes through them. So it tells you that through these 2 points you can draw one and only one straight line. Okay, see, there are 2 distinct points P and Q. Through a given point, how many straight lines can be drawn? See, through a given point you can draw infinite number of straight lines, right? Like L1, L2, L3, L4, L5 and so on. Similarly, through this point you can draw infinite number of straight line like this. Understood? So it is concluded that through a given point, only one point, you can draw infinite number of straight lines. But through 2 distinct points, how many straight lines can be drawn? See, we can draw only one straight line, that is PQ. We cannot draw more than one straight line through 2 given points. You can take any 2 points. Suppose there is a point, here is a point. Then how many straight lines can be drawn? See, only one. If here is a point and here is a point, how many straight lines can be drawn? Only one. But through a given point you can draw infinite number of straight lines. But through 2 distinct points you can draw only one straight line. So this is the postulate number 1. And let us discuss about the second postulate. So the second postulate tells you that a terminated line can be produced indefinitely. Indefinitely means infinitely. Okay. So there is a term terminated line. What is the meaning of this term? Terminated line means a line which has both starting point and ending point. Then tell me, which line has both starting point and ending point? As you know, a line segment has a starting point and it has an ending point. The starting point is known as initial point or origin. This is the ending point. Okay. Now, according to Euclid, he called this line segment to be terminated line. Then what is the postulate 2 tells you that? It tells you, if you want, then you can extend this side in this direction infinitely. Similarly, you can extend this side in this direction infinitely. Right? So, the postulate 2 tells you that you can extend a terminated line in both the direction. Okay? In infinite length. Understood? This is the postulate number 2. Coming to the postulate number 3. It tells a circle can be drawn with any center and any radius. It means you can draw any circle by taking any center. Suppose this is a center, then you can draw a circle like this. If this is a center, you can draw a circle like this. If this is a center, then you can draw a circle like this, like this. So you can draw any circle with any center, and any radius. Any radius means you can take the length of the radius to be anything. For this circle, if your radius will be 1 centimeter, but this circle seems to be larger than this circle, that means its radius must be greater than 1 cm. Suppose this is 2 cm. For this circle, suppose the radius is 0.5 cm. For this circle, suppose the radius is 3 cm. So you can draw any circle with any center O and with any radius. That means you can take the length of the radius to be anything, to be arbitrary. Arbitrary means anything. Okay. Now, postulate number 4. All the right angles are equal to one another. All the right angles means what? Right angles means an angle whose value is 90 degree. So if you draw any right angles, this is a right angle, this is a right angle, this is also right angle, right? And this is also right angle. So any right angles are equal to one another because their value is always fixed, that is 90 degree. Next we will discuss about the postulate number 5. And finally coming to the postulate number 5. Okay, so though the fifth postulate seems to be very long, but its meaning is very concise. It is very easy to understand. So let's understand this postulate. It tells you that if a straight line falling on two straight lines, okay, it means if there are two straight lines like this, L1 and L2, and over this two straight line there is another straight line that falls on it. Okay, that means if a straight line L3 falls on the straight line L1 and L2. Okay, and now if a straight line falls on two straight lines, then such straight line are known as transversal line. Transversal line. Okay, so if a straight line falls on two straight lines, then makes the interior angles. Okay, whenever L3 falls on L1 and L2 straight line, then how many angles here formed? Here about 8 angles formed. See, what are the angles? Angle 1, this is an angle, this is an angle, this is an angle, okay, this is also 7 and 8. So total 8 angles are formed. Out of 8 angles, angle 1, angle 2, angle 8 and angle 7. 1, 2, 7 and 8 are which type of angle? These are the exterior angle, because they lie on the exterior side of this two straight line, towards this direction, towards this direction. And the angle 3, 4 and 6, 5 are interior angles. Understood? Now, whenever this line intersect or meet or falls on this two lines, then you can see there are two sides. Suppose this is a line and this is one side, this is another side. Okay, so in this direction, towards this side, suppose towards the right side, okay, towards right side, then how many interior angles are there? Towards its right, there are two interior angles, 4 and 5. 4 and 5 interior angles. And towards left side, how many interior angles are there? This is the left, 3 and 6. 3 and 6 interior angles. Understood? Next, so if a straight line falling on two straight lines makes the interior angles on the same side. Same side means it has two sides, right side, left side. Okay, so you are considering only one side. Either you consider this side 3 and 6 or you consider 4 and 5. Okay, on the same side of it taken together means the interior angles that you find on one side of this line should be taken together. That means they should be added. Okay, suppose I will take this side 4 and 5. Okay, someone takes this side, that is 3, 6. Taken together less than two right angles. Right angles means what? Right angles means 90 degree. Two right angles means what? 2 into 90 degree, that is how much? 180 degree. Okay, if one side of this line has two interangles 4 and 5 and their sum is less than 180 degree, then the two straight lines, if produced indefinitely, meet on that side. Okay, if it is given that if on one side the sum of these two interangle is less than 180 degree, then if you produce these two lines L1 and L2 indefinitely, okay, if you produce these two lines indefinitely, then at some point these two lines will meet each other. Okay, now you understand. But the condition is what? The condition is on that side where the sum of the interangles should be less than 180 degree. Okay, if it is less than 180 degree and if you produce them towards indefinite direction, then they will meet each other. Otherwise, they will not meet. Okay, see, in the left hand side there are two angles, interangle. Okay, but in this case, the sum of these two angles is greater than 180 degree. If it is greater than 180 degree, then if you extend this two lines, then they will not meet each other at any point. Okay, why? Because the sum of the two interangles is greater than 180 degree. But if the sum of the two angles is less than 180 degree, then on that side, if you produce these two straight lines, then they will meet each other at any point in indefinite direction. Understood? So this is the fifth postulate and it is also very easy postulate. Okay.